Today we're talking about the power rule. And so yesterday I taught you guys the power rule, but you can't just use it all willy-nilly. There are rules to using it. And so today that's what I'm going to go over. Okay? And so when we use the power rule, we're going to have three general steps. So the first one is going to be to rewrite it. I can't write. Rewrite. There we go. Two, the second thing you're going to do is differentiate. This is the step you'll use the power rule. This is where you'd use it. And then the third step is to simplify. And if we looked at yesterday's examples, we'd see that we did these three steps. We're going to rewrite it in a form that we can do it, that we can use the power rule, and then we're going to differentiate, which is using the power rule, and then we're going to simplify it back down. Okay, so let's look at, I don't have any examples set up. I do have, I have two examples here. One is dy, is it dy dx? I'm reading, nope, just d. So d dx of x to the 87th, right? So this looks scary, but really we just take it out, and that becomes 87x. So f prime equals 87x to the 86th, right? Because we know our power rule. Okay, so then here's another example. G of x equals this. So the cube root of x. Gosh. So we're going to rewrite. So step one. Okay, we're going to rewrite that as x to the third. Step two, we're going to differentiate. So we get 1/3 x to the negative 2/3. Because remember, 1/3 minus 1, or 3/3, if you want to think about it that way, equals negative 2/3. And then 3, we're going to simplify, so x goes to the bottom, so 1/3x to the 2/3 power. And then, do I have another example? Nope. Okay. So now, what do we do? So sum and difference. This is another rule that I alluded to yesterday. Sum and difference rules. Which is probably going to be, we'll just title it this. So when you have a sum of derivatives, so let's say the derivative of negative 4x plus 5, right? So we can take the derivative of this piece and the derivative of this piece separately and add them together, and it will be fine. So the derivative of this is actually just negative 4, because the x is going to move down. The derivative of a constant equals 0. This is important. So we can ignore this 5 because it's going to be 0. So 4 plus 0 equals negative 4 is basically what we're looking at there. Same with this example. If we take the d dx of 3x squared minus 4x, it's going to be 6x minus 4. Right? And that's it. Because we can take the derivative of this piece, because it's just like adding a negative number. And because these two terms, so it's 3x squared plus negative 4x. So we're going to take the derivative of this piece, which is 6x, and then we'll take the derivative of this piece, of this term, which leads us to negative 4, and then we just add both of those together, so we get 6x minus 4, because we're really adding them together. But there you go. And difference works this way. So this is the difference. This is the sum. Just treat them similarly. For difference, just move the sign over to the second term, if that makes sense. Hope that was helpful.